Alright, so here's the winning factors for the warm-up. Any questions, any problem here you want to see worked out? Number 3. Okay, today's lesson definitely depends on being very comfortable with factoring. So let's see what happened here on number 3. First step is to ask yourself, is there a GCF? But none of these had a GCF. If there's no GCF, you start factoring. Multiply A times C. So 6 times negative 35. That's going to give me negative 210, right? Okay, now I got to think of all the factor pairs of 210, and I'm trying to add up to a positive 1 in the middle. So that could be 1 and 210, 2 and 105, 3 and you got your calculator there. Just take 210 and divide it by everything you can think of. 3 and what was it, 70? And then the winning pair, you just keep on going. Just try dividing by 4, by 5, by 6, by 7. The winning pair is going to be 14 and 15. And that's why I'm letting you use a calculator, because you probably wouldn't know that necessarily. But 210 divided by 14 is 15. So that's the winning pair. Now I need them to add up to a positive 1. So which one would have to be? Alright, this would be minus and this would be plus. Okay, so then I'm going to rewrite that problem as 6x squared. If you've got one negative and one positive, I would usually write the negative one first. Now the GCF here, and if you don't get the GCF out, it is going to mess you up. Definitely there's an x in common, but what else? Not for 6 and 14. A 2x, right? And you'd be left with 3x minus 7. And the GCF here is a positive 5, and you'd be left with 3x minus 7. Then take out the 3x minus 7, and you're left with 2x plus 5. You did it the other way? It'll still work the other way as well. I just usually like to put the negative one first, because then I don't have to take out a negative GCF on the second step. Okay, anything else on the warm-up? Alright, moving on to today's lesson. You will need your notes. We got a lot of notes to take today. Today we are solving quadratic equations. And guess what we're going to use to solve them? Factoring. This is what all that practice has been leading up to. And you are going to learn how to do this in your calculator as well. And I always have kids who ask me, why didn't you just teach us how to do it in the calculator? That is part of it. I want to make sure you understand what you're doing. And sometimes on the end of course exam, they don't ask you for the answer. They ask you for the process to get the answer. So you do have to know how to do it by factoring. Okay. A quadratic equation normally is a parabola. Okay, and parabolas are those things that look like a U. Sometimes they're, or a smile, sometimes I call them. Sometimes they're a right side up smile. Sometimes it's an upside down smile, a frown. But y'all, we have looked at those shapes before. Y'all are familiar with parabolas? A parabola is in the form of something like y equals x squared minus 9x plus 14. The way I know that that's going to be a parabola is the highest exponent is a 2. Okay, so what we're doing today is we are looking at a parabola, but specifically, not the whole thing, just 2 certain points, usually 2 certain points. We're looking for these parts of a parabola right here, where it crosses the x-axis. In other words, this is sometimes called finding the roots, finding the zeros, or finding the x-intercepts. That's what we're doing today. And those 3 words, you do have to know them. They're used interchangeably. You got to know what it means when you're asked to find the roots or the zeros or the x-intercepts. It means where is that thing crossing the x-axis? And it could be any kind of picture. In particular, with factoring, it's usually some kind of parabola. If your exponent is a 2, it's a parabola. So we're trying to figure out where in the world is it crossing the x-axis. That means the x-intercepts. It's also called the zeros, also called the roots. Why do you think it's called the zeros? What's at 0? The y value. The value of a function is always its y value. And if you're on the x-axis, if you're crossing the x-axis, then your y value is always a 0. Any point on the x-axis has a y value of 0. Let's just look at this particular parabola. And you have your calculators if you want to try this one with me. One thing I want to caution you about, when you're putting this parabola in, this equation in, make sure if there's a minus sign, don't put a negative sign. Like some kids put a negative 9x, and the calculator looks at that as a multiplying problem. Okay, I've told you that subtraction and negative means the same thing, and technically that's true. But this symbol right here is separating these two terms. It's an operation symbol. You cannot put a negative symbol here or it's going to multiply those. So watch out for that. So let's put this together in our calculator. Make sure your picture looks like mine. Y equals x squared minus 9x plus 14. There's my parabola. It's a smile. It's opening up. What we're about to do, y equals x squared minus 9x plus 14. And then you just hit graph and you can look at a picture of it. What we're about to do is not look at every single point. Guess how many solutions there are to this problem? Infinite, millions. It goes on forever. We're only looking at a part of the parabola. Okay, if your picture doesn't look like mine, check to see that you didn't put a negative sign right here, because look what happens. Somebody did this last period. Y equals x squared, and they used a negative sign, and then put 9x, and then put plus 14. Please watch out for that. Do you see how the negative sign is higher? Again, the calculator is multiplying these two things together, and it doesn't look anything like a parabola because it's not. It's making it into some kind of different figure. So watch out for that. This has to be a minus sign, not a negative sign. Okay, now, if I wanted to look at all the solutions, first of all, I couldn't list them all. There's millions of them. If I look at the t-chart, here's a list of all of the solutions. It goes on forever. The answer for y depends on what you put in for x. So if we put a 4 into this problem, we're going to get back a negative 6. You see what I'm talking about? If we put a 5 in for x, we get back also a negative 6. Okay, so there's millions of solutions here. Today we're focusing on very special solutions. This point and this point. Can you just look at the picture on your screen and kind of guess where it's crossing the x-axis? It looks like 2 and 7. And guess what? Spoiler alert, it is going to be 2 and 7. And in fact, if we looked at the table of values, look at 2. What does 2 give us back? A 0. And look at 7. What does 7 give us back? 0. How do I get to the table of values? The table and the picture are the same exact key. If you just hit graph, it shows you a picture. If you hit second function and then the graph button, it shows you the table of values. So yes, we're going to learn a whole way to get the calculator to tell us the answer. Sometimes it's nice and easy and you can get it from the t-chart or from the picture. The answer here definitely is 2 and 7. You have to know how to do it by factoring, though, because sometimes they don't ask you for the answer, they ask you for the process. So let's figure out how we could solve this thing by factoring. And again, these are called looking for the roots, the x-intercepts, the zeros of the function. First of all, you've got to take out the y and set in what we want it to equal. What do we want this thing to equal? 0. We're looking for where this thing equals 0. We're specifically looking for the zeros of this function. So we're not looking at the whole thing. We're just looking at those two very important points. Where is it crossing the x-axis? And if we didn't have access to our calculator, the only way we could do this is by factoring. Okay, now I'm going to back up for a second. Let's just do a little pause on this lesson, and I'm going to show you a little mini lesson real quick, because I want to show you what's going to happen at the end of these problems. First of all, you've got to know something called the zero product property. This is important for this lesson today. Zero product property. That states if A times B equals 0. If you have two things that multiply together and you know that they multiply together to give 0, then you know something about A and B. If you know A times B is 0, tell me something you know. Either A is 0 or B is 0, or they both are. If A times B equals 0, then either A equals 0 or B equals 0 or both of them equal 0, A and B. That sounds like a real simple concept, but that's how we're going to find the solutions. Okay, now what you're going to end up with is two factors. That's what we've been factoring forever and ever. And those two factors are now going to be equal to something. This is new. We never had it equal to anything. It was just a plain old problem, and we were told to factor it, and that's so we could practice these skills. Now it's actually going to equal 0. So let's do this one. Okay, first step, look for a GCF. Is there a GCF? Second step is just start factoring. What's A times C in this problem? 14. And we want the factors of 14 that add up to -9. So we're going to factor it just like normal. That could be 1 and 14, 2 and 7. And that's all. The winner has to be 2 and 7. And what do both of the signs have to be? Negative. Okay, so let's keep on factoring this thing. X squared minus 2x minus 7x plus 14. What can I take out of the first two? Take out an x and you're left with x minus 2. What do I take out of the second two? Take out a -7 and you're going to be left with positive x minus 2. 14 divided by -7 is minus 2. These, remember, should always be the same. So now you take out x minus 2, and what are you left with? X minus 7. And it's still equal to 0. You can put the 0 on the front or the back. Well, no, we're not done. Okay, so we have factored it. We haven't solved anything yet. We have factored it, which is definitely the first step to solving it. Here's the one extra step that we've got to do that we didn't do before because they never equaled anything before. Now we've got these two little baby factors. X minus 2 times x minus 7 equals 0. This is kind of like A times B equals 0. If we know that these are the two factors and that they equal up when you multiply them back to 0, what do you know about each of those factors? One of them or both of them has to be 0. So you're going to set up two little baby equations here. You're going to say, okay, well then either x minus 2 is 0 or x minus 7 is 0. Yes. This crosses the x-axis twice, and you have to tell me both of them. Okay, this is a one-step little baby equation. You want x by itself. X has a minus 2 with it. How do you get rid of minus 2? Add 2. So what does x actually equal here? 2. 2 minus 2 is 0, right? Here I want to get x by itself. It has a minus 7 with it. How do you get rid of minus 7? Plus 7. So what does x equal here? 7. Guess where this thing's crossing the x-axis? At 2 and 7, which we already knew that because we cheated and looked at the picture beforehand. Isn't it crossing at 2 and 7? Now, I want you to be able to do it by factoring. You're not going to I don't want you to use your calculator. Also, sometimes it's not so obvious, not always nice whole numbers here. So the zeros, the roots, the x-intercepts of this particular problem are 2 and 7. Now let me show you how you can show your answer. Sometimes you can write it in set notation. There's two answers here, 2 and 7. Sometimes it's going to be shown as points. Now 2, 7 is not a point that's on this parabola. They make two separate points. 2 goes with what? 0, and 7 goes with what? 0. So another way that they sometimes show this answer is to write them separately, like two different points, and we're always looking for when the y value is 0. We already knew the y value had to be 0. We're trying to find the x. Where it crosses the x-axis, exactly. The x-intercepts, otherwise known as the roots, otherwise known as the zeros, because it's where the function equals 0. No. We're finding two different x values. The y value we know is 0. We set the y value equal to 0. This thing happens to have two two places where it equals 0. It equals 0 right here. That point right there is 2, 0. And it also equals 0 again right here at 7, 7, 0. So it has two different values of x that make the y a 0. It's not like a normal equation. Normally we just have one answer. On these you should have two. Yes. Not really. And well, I did show you a shortcut for these when the a value is a 1. But then you got to do the factoring the long way. All right, let's do another one. Let's try another one. Number 2. Here was the other little mini lesson I was going to show you. Let's say you had this little baby equation, because I would hate for you to get the factoring right and get down to this step and miss it. If 2x minus 3 equals 0, that's a silly little tiny baby equation. Don't let that trick you. What's the first step in solving that? Okay. No, you want x by itself. What are you going to do? Yeah, it is 1.5. You add 3, yes. Add 3 to both sides. You would get 2x equals 3. Then what? Divide by 2. So what would x equal? 3 halves. 1.5. Yeah, 1.5 and 3 over 2 is the same thing. What if you had this problem? 5x plus 1 equals 0. Okay, what we're doing is solving baby equations. For some reason, when we get to this very last step, I have kids who do all this complicated factoring. They get down to the very last step, which is going to be something like this, and they mess up. Your job on the last step is to get x by itself. How do I get x by itself in this little baby equation? Subtract 1. You get 5x equals negative 1. Then what? Negative 1/5. Exactly. What if you had 3x minus 2 equals 0? Look at this little baby equation. What's the answer here? Add 2 to both sides. And then divide by 3, 2/3. You're going to get lots of problems that are going to have fraction answers. So I don't want you to mess up on this very last step. The thing that's not normal about this problem is you're not used to seeing a linear equation equal to 0. You're not used to seeing this kind of problem. You just got to move the number back over and then divide by whatever's in front of x. So what if you had 7x minus 5 equals 0? What's the answer going to be? Five over 7. You add 5 to both sides, then you divide by 7. Right, it's the opposite sign, and then you always, whatever's in front of x ends up on the bottom of the fraction. Exactly. Okay, so the more you do these, the faster you get. What if you had 3x minus 8 equals 0? What would that be? Positive 8/3. You see what we did there? We moved the 8 over, then we divided by 3. This would be 3x equals 8, then divide by 3. What if you had 2x plus 5 equals 0? Negative 5 over 2. Are you with me? You would subtract 5, then you would divide by 2. Okay, let's talk about why I wanted you to see that. Because sometimes your answer will have a fraction, like this one right here. 3x squared plus 8x minus 3 equals 0. What's a hint that I'm finding the zeros? It's equal to 0. Exactly. And finding the zeros just means you're finding the x-intercepts. Another word for that is the roots. So as soon as I see this problem and I see it's equal to 0, I see an exponent of 2, I'm picturing some kind of parabola in my head, and I'm trying to find where it's crossing the x-axis. Otherwise known as the roots, otherwise known as the x-intercepts, or zeros. Now, I can also tell I'm probably going to have a fraction answer here. Guess how I can tell that? Because there's a number in front of x squared. There's not a nice invisible 1 in front of x squared. That's usually going to indicate a fraction answer for one of your roots. First step is always look for a GCF. Is there one? No, just start factoring. What's a times c in this problem? Negative 9. So we're looking for factors of negative 9, which could be 1 and 9 or 3 and 3, and they have to add up to a positive 8. So what's the winning pair? 1 and 9. And I need the 9 to be positive and the 1 to be negative. That's how they're going to add up to a positive 8. And that's very important. If you get your signs wrong, your answers will be wrong. So now, I have a positive 1 and a negative 1. Which one should I write first? Which one's usually... The negative one's usually easier to put first. You can do it either way. Yes. Okay, so I rewrote the positive 8x as a negative x plus 9x. Now I'm going to GCF this thing. What's the GCF of the first two? X, and you're left with 3x minus 1. What's the GCF of the last two? 3, and you're left with 3x minus 1. Now you take out 3x minus 1, and you're left with x plus 3. On our old problems, that's where we stopped. We were factoring, and that was it. It never equaled anything before. Now it equals something. We can't stop yet. Now we have to do that extra little step. Each factor has to be set equal to 0, and you've got to solve it for x. So if this times this equals 0, that means 3x minus 1 could equal 0, or x plus 3 could equal 0. And here's what we just practiced right here. This is a two-step problem right here. What do you do with that negative 1? Add it to the other side. Move it over. You get 3x equals 1. Now what? Right, divide by 3. 1/3 is one of my roots. This one's super easy. If x plus 3 equals 0, what does x equal? Negative 3. You got to move that 3 to the other side. So where is this thing crossing the x-axis? At positive 1/3 and negative 3. I'm going to look at this just to verify that. I'm going to put this into my calculator. Y equals 3x squared plus 8x minus 3. Okay, now let's look at a picture of it. Does negative 3 look correct? Looks correct to me right there. And then the other one is somewhere between 0 and 1 at 1/3. That looks reasonable to me as well. Okay, the y value is 0. We're trying to find what x number makes this y value equal 0. And there's two x values that work. Let me plug in a negative 3 and show you. Let's put a negative 3 back into the problem. What's negative 3 squared? Okay, one of my answers was negative 3. Negative 3 squared is positive 9, and 3 times 9 is 27. Plus 8 times negative 3 is negative 24. Guess what 27 plus negative 24 minus 3 is? 0. So if I put a negative 3 into this problem, what do I get back? 0. Guess what's going to happen if I put a 1/3 into this problem? Guess what I'm going to get back? 0. Okay, here's how you write your answers then. You can just write it like I did. X equals 1/3 or x equals negative 3. Or in a set notation, 1/3, negative 3. Those are the zeros of the function. If I put in those two values, I'm going to get back a 0. Or you could put it as points. 1/3 0, comma negative 3 over 0. Yeah, you could put the negative 3 first and the 1/3 second. This is what I don't want you to do. Why shouldn't you write it like that? That looks like a point. These two don't make a point together. They make two separate points. They're both x values. They're not both y values. Each one of those is an x value, and the y value that goes with each one is always a 0 because we're finding the zeros. Yeah, this is set notation. The squiggly parentheses means this is the set of answers for x. No, I'm not even close to being done with you guys. We've only done 2 problems. You haven't done anything by yourself. All right, you try this one, please. (3x squared plus 14x minus 5 equals 0). First step you always should do is ask yourself, is there a GCF? I don't want you to get out of that habit because we're going to be doing several that don't have a GCF, but please don't get out of that habit. Is there a GCF here? No. Then you start factoring like normal. Okay, and when you get your factors, just remember you're not done. You have to take each factor, set it equal to 0, and solve that little tiny baby equation. Okay, are we at least done with the factoring? Okay, for my factors, I ended up with 3x minus 1 times x plus 5. Did y'all get that? Again, your factoring skills have got to be good to be able to do these problems. Are we okay with the factoring? One extra step. This kind of factor is super easy to solve for x. If x plus 5 equals 0, what does x equal? Negative 5. So what point do I know is on this graph? Negative 5 comma 0. Now, what about this one? If 3x minus 1 equals 0, then the answer would be 1/3. You move the negative 1 over, you add 1 to both sides and move it over, and then you divide by 3. So the other 0 of this function is 1/3. There are two answers here, 1/3 and negative 5. If I wanted to write them as points, it would be 130, negative 50. And if you had a calculator, what could you do? Look at it, go to y equals and look at it and see if that looks even reasonable. Y equals 3x squared plus 14x minus 5. Oops. Forgot to clear out the old stuff. Forget it. Let me just start over. Y equals 3x squared plus 14x minus 5. Now, our answers were negative 5 and positive 1/3. Does it look like it's crossing at negative 5? That looks reasonable to me. And I can even look on the table of values and look at my x value of negative 5. What should I see across from it? A 0. Now the one I can't see yet, I will teach you how. I can't see the x value of 1/3 on my t-chart, but I could look at the picture. Does that look reasonable? Positive 1/3? Yeah, that looks reasonable to me. So that makes me feel like I did it right. It's crossing the x-axis at those two places. Alright, we still need to look at the weird cases. Weird cases, which will happen. Here is a weird case. X squared minus 16 equals 0. Some of you had a real hard time factoring this type of problem. What's missing in this problem? The b. If the b is missing, what does this usually turn into? Or what does this usually mean is going to happen here? The middle b is 0. 0x is in the middle. But when the b is not there, that's usually an indication that you're looking at the difference of two squares. Is this a difference and are they perfect squares? Yes, that means it's super easy to factor. What does it factor into? X plus 4, x minus 4. So what are the solutions? This one would be negative 4. If x plus 4 equals 0, then move the 4 over, you'd get negative 4. What would this one be? Positive 4. Okay, and if I wanted to verify that, look at your calculator, go to y equals, put in x squared minus 16. Look at the picture, and it should be crossing the x-axis at positive 4 and negative 4. That looks right to me. What are the points then if I wanted to write these as points? 4, 0, negative 4, 0. Those are the two places where this thing crosses the x-axis. What is another word for x-intercepts? Roots. What's another word? Zeros. X-intercept, zeros. Roots, same thing. All right, here's another weird case. Sometimes you're going to have an exponent that's higher than a 2. Let's look at one like that. How about x to the third power minus 25x equals 0? Guess how many times this thing crosses the x-axis? 3 times. This is not a parabola. This is something else. It's going to look something like this. It's going to cross once, twice, 3 times. Okay, now we can still solve this even if we didn't have a calculator by factoring. What's the first step on any factoring problem? Take out the GCF. There's definitely a GCF. First of all, you cannot start factoring when you've got an odd number there. You just cannot. And the reason why I have an odd number in there, right there, is because there's a GCF on these two terms of what? Of x. We've got to get an x out of there. What's left? X squared minus 25. Now, let's stop right here, because we already know one of our answers right now. We're going to have 3 factors, not just 2 factors here, because this exponent's a 3. I already found one of the factors. What is it? X. If x is if there's a letter in your GCF, then 0 is always one of your answers, because you've set each factor equal to 0 and you solve it. Well, if you set x equal to 0, it's already solved. One of the places where this crosses the x-axis is 0. So I'm done with that factor. I found the answer. Okay, now I'm not done with this though. This still can be factored. It's missing the b. Once I got the GCF out, it's missing the b, which means it's the difference of 2 squares. This factors into x plus 5, x minus 5. So do you see how here are my 3 factors? So either x equals 0, or x plus 5 equals 0, or x minus 5 equals 0. Well, this one's already solved. 0 is one of the answers. What's this one going to be? X equals negative 5. What's this one going to be? X equals positive 5. And if we looked at a picture in our calculator, it's going to cross at 5, at 0, and at negative 5. Crosses 3 times. Okay, how to put this one in your calculator? Go to y equals. Let's go x to the third power. You got to use that little caret symbol. Minus 25x squared. Oh wait, I'm sorry. X to the third minus 25, just x. Y equals x to the third. I'm having trouble today. Y equals x to the third minus 25. Y equals x to the third minus 25x. Yes. Okay, now let's look at a picture. Okay, now it's really close to the y-axis. It's kind of hard to see, but it's going way up and then back and then up like this. Look, where is it crossing right here? Negative 5. It's crossing right here at 0, and it's also crossing again at positive 5. Okay, let's look at another weird case, because you will come across these. I want to make sure you know what to do. Oh, in the squiggly line form? In the set notation form, it would be 0, 5, and negative 5, in any order. 0, 5, and negative 5. As points, it would be 0, 0, 5, 0, negative 5, 0. Yes, absolutely. Okay, what about this problem? 3x squared minus 15x equals 0. What's missing in this problem? It's not normal to factor a binomial. That's an odd case. What's missing here? The c. We've got the x squared, we got the x, we don't have a constant at the end. If the c is missing, how do you know it's a, b, and c? A is always in front of x squared, so I have an a number. B is always in front of x, so I have a b number. C never has a variable with it. So the c is missing here. So if the c is missing, that's almost always a GCF problem. Sometimes the only thing you can do is GCF it. Are y'all listening? You always look for the GCF first anyway. What's the GCF here? 3x. And what's going to be left? Okay, I am done factoring because I don't have any more exponents. My factors were not two binomials here. My factors were a GCF and a binomial. No, I'm not looking for factors. I'm looking for solutions. One of them is 5, absolutely. No, what's the other one? 0. If 3x equals 0, what does x equal? Yeah, 0 divided by 3 is 0. 3 times some mystery number is 0. That number has to be 0. If x minus 5 equals 0, what does x equal? 5. This thing is crossing the x-axis at 0 and at 5. What? What now? Okay, let's go back. You don't divide 3, you divide by 3. Anytime your GCF has a letter in it, let me just tell you, 0 is always one of your solutions. Look at this equation right here. 3 times some number is 0. What's the only thing that would work here? 3 times what gives you back 0 as an answer? 0. The way you solve that equation is you divide by 3. Well, 0 divided by anything is what? 0. And if you looked at this picture, it's going to cross at 1, 2, 3, 4, 5. And at 0, it's going to look like this. It's crossing at 0, 0, and at 5, 0. Okay, last one, and I'm going to let you guys do this one all by yourself. 2x to the third power minus 2x squared minus 40x equals 0. How many answers should this have? 3. This is going to be one of those snake-looking deals that's going to cross the x-axis 3 times. All right, you try this one, please. First step is always what? GCF, and there is definitely a GCF in this. Ladies, let's go. GCF. What's the GCF here? 2x. Right away, if my GCF has a letter in it, I know one of my answers has to be what? 0. Okay, when I take out a 2x, I'm left with x squared minus x minus 20. You got to keep factoring this. What did it factor into? X minus 5 times x plus 4. So here's my three factors. That means either 2x equals 0, or x minus 5 equals 0, or x plus 4 equals 0. So what are my three possible answers for x? 0, 5, and negative 4. Those are the three places where it's going to cross the x-axis. Those are the three zeros. Those are the three roots. You could write them as points, 0, 0, 5, 0, negative 4, 0. Or you could just write them just like I did. Or with the fancy squiggly lines. Okay, so how do you feel about this? Your homework, which we're going to start right now, is page 190, 10 through 24, all of them. You got to get some practice in on these. It's like 15 problems. We're going to go over it next time.